We're going to start with 1.3, so real numbers. We were talking about categories, so just to refresh. The categories we had talked about were natural numbers. The questions you would see on a test, yeah.
I just had a quick question about homework. So yesterday we went through section 1.1 to 1.3. Does that mean that last night we should have done homework 1.1 through 1.3?
I would say yes,
Okay.
but not in terms of I'm collecting it today to grade. But yeah, anytime we,
Right?
yeah, so anytime we do section 1.1 and 1.2, one day we started 1.3, I would go home immediately and do those sections. So that way you guys can come in with questions. I was gonna finish 1.3 and then ask for questions on whatever you guys have. Yeah, usually I start classes that were kind of left off in the middle of the section. Yeah.
So the homework that's due tomorrow is 1.1 through 1.3.
No, 1.1 through 1.6 or 7, whichever one we finish today. Yeah, I know, it moves fast. Summer course, usually yesterday and today makes a whole week, and then the homework would be due next week. But I don't want to accumulate a whole week's worth of homework, because that just means everybody waits till Sunday night, and then that's hours and hours of work, and then doesn't learn anything from it. Yeah. So, we've got natural numbers, which are naturally the way we count. That's the easiest way I remember it. 1, 2, 3, 4, 5, right? We've got whole numbers, which are often misused to mean integers. But what whole numbers are just the natural numbers including 0. So 0, 1, 2, 3, 4. And then integers. And this is the one that's most common, that you'll see most in the book in terms of questions and problems. And this means all the positive and negative natural numbers and 0. So all of them together, so negative, whatever number you want to start with. So those are the ones we talked about yesterday. The questions on the homework and the questions on the test would be something like, give an example of an integer that is not a whole number. So what would be an integer that is not a whole number?
A negative.
Yeah, but a negative, like, give me an example, because there's definitely negative numbers that don't fall into that category. So an integer that is not a whole number might be.
1/2.
No, not 1/2, because that wouldn't be an integer, right? So, give me an example of an integer that's not a whole number. So in other words, give me an example of something that falls into this category, but does not fall into this category. Yeah, -1, -2, so when you say negative number, that's half correct, but it needs to be a negative integer or a negative whole number. It can't be -1/2, -3.1, -3.7, because those are not integers. So that's what the homework's going to look like. That's what the test question on this is going to look like. In general, I'm not a huge fan of memorization, but these are just a few vocabulary words that you'll have to know. Right? The other category is rational numbers and irrational numbers. And this is a divide. Every number is one or the other. There's no middle ground. Right? Whereas each of these categories is just this teeny little subset of special numbers, this teeny little group. Whereas rational numbers, right, these are numbers that can be written as a fraction of integers. In other words, so i.e. a over b, where a and b are integers. Right? Now that's a rigorous definition, not one you're going to have to know. But specifically to apply it, what that means is, so okay, so specifically, you got all integers, right? Because every integer could be written as 5 could be written as 5 over 1, -7 could be written as -7 over 1. got all fractions, well, I'm saying fractions, but obviously I mean fractions of integers, like 3/4, 5/7, that's obviously a rational number because that's the definition. And then the other ones that fall into the category are terminating decimals, so decimals that stop, and repeating decimals. So decimals that repeat over and over and over. Just repeating decimals. Okay, and specifically those are the ones that you'll need to know. Irrational numbers is seemingly a much smaller subset. And this is the last category. Everything is either rational or irrational in the real numbers. Yeah, it's the easiest way to define them, is just say they're not rational. Specific examples, okay, I'll actually do it over here, but I'll write it right here. The most common examples are just square roots that don't work out nicely, so like square root of 2, square root of 3, square root of 5, not square root of 4, because that's equal to 2. But the square roots that don't work out nicely, and things like pi or phi or, you know, the gravitational constant or constants that arise from nature, transcendental numbers, things like that. So, actually I'll do it over here. Give some examples of rational versus irrational. Right, we just saw we could do square root of 2, square root of 3, square root of 7, square root of 11. These are all irrational numbers. Pi over 2, okay, phi, which is another constant. Rational numbers is everything else. So we got things like 2, 3.1. The reason 3.1 is a rational number is we could write it as 31 over 10. Okay? Or 4.33333 repeating, because that's equal to 4 1/3 or 13/3. Right? So repeating or terminating decimals we can turn into fractions. Square root of 9 is a rational number, because that's equal to 3 or 3 over 1. All right. Perfect. Okay, so we got 2 more things to talk about, and then we'll go over the homework, see if you guys have questions. So the nice thing about real numbers, as we were talking about yesterday, they all lie on the number line. So every number is either ahead of, either greater than, or less than every other real number. So here's 0 in the middle. We go up 1, 2, 3, 4. We go down -1, -2, -3, -4. And it continues on and on. Okay, so a couple homework problems will look like, it'll give you some numbers and say, place them on the number line. They'll say place 3.1 on the number line. Place, 3/4 on the number line. Place -0.75 on the number line. Then after that, it gets to comparing numbers. And that's what we're going to talk about right now. To compare numbers, we use inequalities and equalities. I mean, you can always say something's equal. The inequalities as read from left to right. Go like this. This means greater than. This means greater than or equal to. less than, and this means less than or equal to. So a couple examples from your homework. Would be okay, so 46. It says place one of those 4 signs in between these 2 numbers. So there's a 4, a blank, a -3. 50, so getting harder, is -5/2. There's a couple layers to this. -5/3. And 58 is square root of 3 and 2. Right, and as I said, every single one of these is exactly the same as the odd number right before it, just with a different number. So 45 is really similar to this. 49 is really similar to this. Okay, so for the first one, which number is greater? Yeah, so positive numbers are above, and that's why I like thinking about this vertically. Positive numbers are above the negative numbers, so we say it's bigger. So that means the big side is on the 4, and the teeny little side is on the 3. Okay, one way I always draw it with my middle schoolers, which is helpful, is the hungry alligator always likes to eat the big thing, right? Always chooses the big prey. So I draw my crazy alligator with eyes going everywhere. Okay. Now 50, same question, but harder because now it's a fraction, now it's negative. Right, so which one's greater and why? This is going to take a little more logic, so I'd love to hear the logic behind it rather than just, an answer.
When she combine these two things, or not, mixed fraction?
You totally good. Where you write them as decimals, you write them as percents, yeah, for sure. So let's write this as -2.5, and this is -1 2/3. Perfect. That's a lot more clear, yeah. Which one is greater? Why is that? Yeah, exactly. If you go over here and you look at -1 and -2, the -1 is higher up, so it's greater. So yeah, kind of counterintuitive at first. I mean, you see 2.5, which is a bigger number, yet because they're negative, this one's actually greater because it's higher up in the real numbers. So it'll look like this. Okay, and then the last one, what about square root of 3 and 2? Somebody other than Michelle. Michelle, help me out with that one. Not 58. Right, I mean, this is the time you could use your scientific calculator, but yeah.
2 is greater?
Yeah, and why? How do you know?
Because the square root of 3 would be like a really small, never-ending number.
Yeah, or like give me a ballpark number, anywhere close, doesn't even have to be close.
Like 1 point something?
Yeah, exactly, it's gonna be between 1 and 2, and we know that because square root of 1 is 1, and square root of 4 is 2, so square root of 3's gotta be somewhere in between, and that's the sort of logic that to me is much more useful in life than, just like punching a calculator and do numbers, right? So that kind of logic, so square root of 3's gotta be somewhere between. Square root of 2 is around 1.4, and square root of 3 is around 1.7, but yeah, exactly, it's gonna be 1 point something. So 1.7-ish is less than 2. Yeah, perfect. Or calculate. That's the sort of thing where I'm saying you can use the scientific calculator always, but you don't need to. Okay, so that's one of those places where you can use logic, you can do it with pencil and paper. All right. The next problems after that, really similar. They write, well, I'll leave that up there. They write some symbols and just ask you if it's true or false. Okay, so looking at 64, it's -5 is less than or equal to -8. 68 is 0 is greater than or equal to -13. Okay. So what about those? About that first one? Would we write true or would we write false? And again, we have this number line over here that we can kind of forget. So that means go y. What do you mean? Up here?
Oh,
Oh, the second one? Okay, so explain the second one. So, yeah.
oh, no, number 9, 0 would be greater than
Yeah, it doesn't even matter what number this is. 0 is greater than negative anything, right? Negative 0.0001. 0 is above every negative number. So yeah, this one's true. Perfect. And what about the first one? No, thank you, Betsy.
It's false. Even -5 greater than -8.
Why? How do you know?
Because it's closer to 0.
Yeah, it's closer to 0. It's higher up. Negative 8 is 8 feet below the ground. Negative 5, 5 feet below the ground. Okay, so this one, yeah, false. Perfect. And you visit that. Okay, so those are the sorts of questions you'll see with that. The last piece of 1.3 that you'll see are absolute values. And there's a couple different ways to think about absolute values. I think about everything in math differently than people. And that to me is helpful. Maybe for other people it's confusing. Okay, so for absolute value, I'm gonna write something first, and then I'll tell you what an absolute value is. So integers are actually vectors. And do you guys remember from physics, usually that's where you learn about vectors, what a vector is, anybody? Exactly. So what that means is, an integer, and it doesn't even have to be integers, I'm just using integers for example. We could say real numbers. Okay, but I'm just using integers for example. Are vectors, meaning they have a length and a direction. Right? And what is the direction we're talking about here? Thinking back to all these numbers, right? What part of it represents their direction? All right, I'll help you. Okay, so positive 5 means go 5 in the positive direction from 0. Right? Negative 3 means go 3 in the negative direction. From 0. So there's two ways to think about an absolute value. Either you could think about an absolute value always making everything positive, which is the first definition I'll give you, or you could think about the absolute value really saying, get rid of direction. I don't care which side you went on, if you went left or if you went right, how far are you from 0 is really what's happening. Because you can do an absolute value in more than one dimension. If you were doing, and you don't need to write this, but if you were taking the absolute value of the 0.34, and in more than one dimension we call it magnitude, but it's the same thing. The question is, the absolute value of 3, 4 is how far it is from 0. So the absolute value of that point would be this distance, which coincidentally, since I made it up, is a nice 3, 4, 5 triangle. And so the absolute value of that point would be 5, because it's 5 away from the origin. I found that with Pythagorean theorem. So that's why that idea of how far you are from 0 is more useful often. And also as we get to solving absolute value equations and inequalities, you'll see it's a little more useful when you get greater than, absolute value of this is greater than 3. That means it's further away from 0 than 3, or closer than. And so that's why I just bring this definition up. But again, you can think of it in two ways. Okay, so the first way you can think about it is absolute values make everything positive. Or you can think of it as absolute value gets rid of direction and asks how far you are from zero. Okay, so just a couple quick examples, and then we'll go over some homework problems. Okay, so here's some examples really quick. Not from the book, just made up. So absolute value of -2. When I draw absolute values, I make my lines incredibly tall, like comically large. And the reason is again, like I think I told my 11 o'clock class this, I didn't tell you guys, but there's one mistake that I laugh at my students for, and only one. I usually, when people make mistakes, I'm like, oh, you were so close, like I really want you to get that. But the one mistake I like laugh when I see is when people can't read their own writing. And so like when people turn absolute value of 6 into 161. So like that mistake, I'm like, ah, killing me. So I'm always thinking like, what's a careful way I can avoid any mistakes at all so I can do very good work, is I make my absolute values like ridiculously tall, and that way I would never mistake them for ones. Because otherwise, yeah, I mean, I write sloppy, I mean, you can tell my writing's not beautiful, so it leads to more mistakes. So just bringing that up. So we got absolute value of -2, absolute value of 1, absolute value of 0, and absolute value of -1.46. Okay? So what would these be equal to? This would be 2. 1. So so a common mistake is, yeah, people would just say it switches the sign, it makes a positive into a negative. But our general rule, the easiest way to think about it, is absolute values just make everything positive. Gets rid of the positive, gets rid of the negative, just comes out as 2 or 3 or 5. Never comes out as negative. So absolute value of 0 is? 0. Again, it could be asking how far are you from 0? If you were at 0, you were exactly 0 away. And then absolute value of -1.46? That's it. 1.46. Okay. And that's the end of 1.3. So do people have questions?